Welcome to Neuton AI. In this tutorial, you will learn how to quickly get started with the platform and perform the most common tiny machine learning tasks, such as recognizing human activities, performing predictive maintenance of vehicles or equipment, monitoring device conditions and physical assets, detecting gestures, determining vital signs, building human-machine interfaces. In the Use Cases tab, you can explore a rich collection of preloaded use cases for these types of tasks. Let's create your first TinyML model for air writing digits recognition. Go to the My Solutions tab. This is your main workspace where you can see a list of all of your previously trained solutions. You can enter any solution to see the details or to download the trained model. To train a new model, click Add New Solution button. Choose a task type, classification, regression, or anomaly detection. Give your solution a name. Click Next. Right away, you can see the three main steps that the training will go through. So you upload your dataset in the Dataset tab, define the training parameters in the training pipeline, and download and assess your results in the Results tab. You can upload the new dataset by dragging and dropping a CSV or a zip archive. You can select any of the datasets you've uploaded for your other solutions previously, or you can browse the preloaded use cases which are pre-configured to demonstrate the platform capabilities in different domains. Let's upload a new dataset. Click OK. In the Training Dataset tab, you can click Lens to view the dataset that you have uploaded. This particular dataset includes 6 axes of inertial data, accelerometer and gyroscope, and a class column, which represents the label of the activity that is currently being presented in this subset of data. The only requirement at this step is to select the target column. Here are all the columns in your dataset. This is the target column. You can also select a session ID column if you have this attribute in your data, which will help us split the dataset accordingly for validation purposes and help us train a more robust model. You can also drop variables if you don't want them to be a part of your model. If you want to validate your model on a separate hold-off validation dataset or a test dataset, click this toggle and upload the test dataset here. Otherwise, the platform will perform cross-validation. Click Next. On the Training Pipeline tab, if you have uploaded a raw dataset, then you need to enable signal processing. Otherwise, if your dataset has already been pre-processed and you just want to train the model without any feature engineering, then don't enable signal processing. In our case, we have to enable signal processing. And here you have a choice, manual setup or guided setup, which is a simple wizard that helps you through the process. Let's go with manual setup. The most important parameter to configure is the windowing size, based by a number of rows or a time interval, or if you don't know the window size, you can select auto determination and the platform will determine the window size accordingly. Let's go with number of rows. A window is a subset of data that will be interpreted by the platform to extract features. In our case, each one of the air writing digits gestures that I've been collecting took around 1 second. I know that the data collection frequency is 100 Hz, so that means in 100 records of data collection, there is 1 second of data. I'm going to select 100 as a window size. An additional window configuration is sliding shift for training. This will help you augment new training samples from the existing data. By default, it is set the same as window size. This means that there will be no overlap when splitting the data. But if you want to create more samples from the existing data, you might want to select a sliding shift of 25 or 50, and this will create a new window with a 50% overlap of the previous window. An important thing to note here is that if your data represents continuous movements, like drawing circles in the air, then sliding shift is applicable. But if your gestures have a definitive start and end, then an overlap is not applicable and your sliding shift has to be the same as your window size. Another setting is sliding shift for inference. This does not impact training. For example, if you want your model to make a prediction every 5 times per second, then this should be the setting for the sliding shift for inference. The next section is feature extraction. These are all the features that the platform can automatically extract from a sample of 100 records in your dataset for any given axes: accelerometer X, Y, Z, and gyroscope X, Y, and Z. By default, it is configured for the best trade-off in terms of accuracy and footprint, but you are free to select any of these features and have the platform create them for you automatically, and then have the model train on these features to predict your target variable. You can also enable feature selection and select more features so that the platform will create all of them at the data generation step, and then select the most important ones and remove the irrelevant data. On the right side is input data configuration. Data type is determined automatically when you ingest the dataset into the platform, but you also have manual control over data types. Since we're predicting more than 2 different gestures, then we have to select multi-class classification. And an evaluation metric is set at accuracy by default, but you are free to choose any relevant metric for your specific use case. The following settings, such as weights and coefficients, activation functions, and output format, depend on the hardware that you're going to deploy your model into, and will also impact the overall model footprint. To have a smaller model, choose an 8-bit quantization. The training stop options provide you control over when to stop the training process. If you disable everything, the training will continue until the model starts to overfit, and then it will stop training automatically. But you have an option to stop the training at a certain accuracy level, or after some time, or after the model will reach a certain number of weights and biases. The last required option is to select the target hardware. Let's go with Cortex M33. Start training. You will be redirected to the Results tab, where the training progress is going to be displayed. You can input your number to have the platform notify you when this is finished. After the training is over, the Results tab will show you how long did it take, what is the validation accuracy, what is the trained model footprint in terms of flash and RAM, broken down into its components: the model, inference engine, and signal preprocessing. The Solution Options space stores all the models that have been trained along the way. Here you can see all the models' accuracies and their corresponding footprint. And if you want to opt in for a smaller model, check its accuracy. If that is acceptable, select it, and everything will be recalculated for this particular model, and you can download the C library with this particular model. Down below you can see the model quality diagram with all the validation metrics corresponding to this type of problem. There is a numeric value for each of the calculated metrics, and you can see a graphical representation on this plot. On the right is the feature importance matrix, where you can see the ranking of all the extracted features based on their importance for this particular model. You can look at the top 10 and bottom 10. Down below is the confusion matrix, where you can see how good the model performed on each of the classes in your training dataset. There is also a data analytics tab that shows you additional statistics about your data and its relation to the target variable after the feature extraction process. To download the trained model, click Download C Library button. The archive contains everything necessary to embed the model into your target hardware. If you would like to validate the model on an additional holdout validation dataset without embedding it into your target hardware, go into the Artifacts folder and Inference Runner. And here you have command line tools for Linux, Mac, and Windows that will help you predict on the new dataset in a CSV file format. This will allow you to perform an unbiased validation on your own.